Hello students, imagine this. You're solving a maths problem, but half the class decides that plus means minus and minus means plus. Total chaos, right? Well, in optics, the same confusion could happen if everyone measured distances in their own way. That's why physicists came together and said, let's make one universal rule. This rule is called the Cartesian sign convention. It tells us exactly how to treat distances, directions, and positions in lens and mirror problems. Here's the idea. We always assume light travels from left to right. Distances measured against the light's direction are negative, while those along the light's direction are positive. The same logic applies to heights. Upward is positive, downward is negative. Simple, neat, and consistent. Think of it like traffic rules. If everyone drives on whichever side they want, we'll have accidents everywhere. But once we all agree to drive on the left or right, the roads become safe and predictable. In the same way, the Cartesian convention keeps lens problems organized and accident-free. So today, we'll dive deeper into how this rule works, why it's important, and how it makes solving lens problems as smooth as following road signals. Hello students, imagine you're in a cricket stadium. The bowler's end is taken as the origin, just like the optical center of a lens is taken as 0. Now, every run scored towards the batsman's side is considered positive, and if somehow the batsman runs the opposite way, well, that's unusual, but in our math world, that would be negative. In the same way, in the Cartesian sign convention, the optical center, O, of the lens is the origin, our starting point. The principal axis is treated as the x-axis, a straight line through the center of the lens. Now here's the rule, distances measured to the right of O are taken as positive. Think of it like walking forward into the future, positive progress. Distances to the left of O are negative, like walking backwards, which most of us don't enjoy unless we are trying to show off dance moves. This simple rule saves us from total chaos in lens calculations. Just like traffic rules keep vehicles from colliding, sign conventions keep our formulas neat and prevent confusion when solving numerical problems. So remember, origin at O, right side positive, left side negative. Easy, logical, and absolutely essential for solving lens problems with confidence. Alright students, let's talk about how we measure distances in lens problems. Think of the optical center, O, as your home. Now, whenever you place an object, like a candle or a pencil, you usually put it on the left side of the lens. That means the object distance, which we call U, is always measured from home base O to the object. And since it's on the left side, poor U usually ends up being negative. Kind of like standing on the wrong side of the road, still important, but negative. Now comes the image distance, written as V. This one depends on where the image shows up. If the image forms on the right of O, then V is positive. That's like moving forward in a race, good progress. But if the image shows up to the left of O, then V becomes negative. Almost like when you try taking a selfie but your camera flips it to the other side, feels strange, but the rule says it's negative. So, to sum up, object distance U is usually negative because we keep objects to the left, while image distance V can be either positive or negative depending on where the image pops up. This little rule makes solving lens problems much simpler and saves us from a lot of confusion, like knowing which side of the cricket pitch you're batting from before swinging the bat. Now students, let's talk about the focal length sign rule. Imagine you're standing at the optical center, O, like the referee in a football game. The principal focus, F, is the goalpost where all the light rays want to meet. For a convex lens, the focus lies to the right of O, that means the focal length f is positive. Like scoring a goal in the opponent's side, everyone cheers, it's a positive outcome. But for a concave lens, the principal focus lies to the left of O. So here, f is negative. It's like kicking the ball back into your own half, not really exciting, but hey, rules are rules. And now, the magic formula that ties everything together, 1 by f equals 1 by v minus 1 by u. This lens formula works perfectly only when we follow the sign conventions properly. So remember, convex lens focus on the right f positive. Concave lens focus on the left f negative. These simple rules keep all your calculations neat, tidy, and free from silly mistakes, just like traffic lights keep cars from crashing into each other. Alright students, time to put our sign conventions into action with a real example. The problem says, an object is placed 20 centimeters to the left of a convex lens whose focal length is 10 centimeters. We need to find where the image will form. Step 1. We start with our trusted lens formula, 1 divided by f equals 1 divided by v minus 1 divided by u. This is like the golden recipe for lens problems. Step 2. Now, let's plug in the values. The focal length is plus 10 centimeters because it's a convex lens, and the object distance is minus 20 centimeters because the object is on the left side. See how our sign rules are already saving us? Step 3. Substituting them, we get 1 divided by 10 equals 1 divided by v minus 1 divided by negative 20. But wait, minus into minus is plus. So it becomes 1 by v plus 1 by 20. Step 4. Now, shift terms around. 1 divided by v equals 1 divided by 10 minus 1 divided by 20. That gives us 1 divided by 20. Step 5. Flip it around, and v equals 20 by 1, which is 20 centimeters. Oh wait, careful with fractions. Actually, it's 20 divided by 3, which comes out to about 6.67 centimeters. So the image forms at a distance of 6.67 centimeters to the right of the lens. Notice how each sign and calculation led us there step by step, like following a GPS. One wrong turn and we'd have ended up lost in the math jungle. And that's the beauty of sign conventions. They guide us safely to the correct image position every single time. Alright students, let's quickly recap the sign convention rules, the golden traffic rules of optics. First, the optical center O is always our origin, and the principal axis is the x-axis. Think of it like the starting line in a running race. Everything is measured from there. Second, any distance measured to the right of O is positive. To the left of O, it's negative. Just like when your teacher says, step forward in class, positive move. But if you step backward, that's definitely negative. Third, the object distance u is generally negative because we usually place objects to the left of the lens. Poor, u never gets to be positive in most cases. Fourth, the image distance v depends on where the image forms. If it forms to the right of O, v is positive. If it pops up on the left side, v becomes negative. Simple rule, right is bright, left is less. Finally, the focal length f. For a convex lens, f is positive because its focus lies to the right. For a concave lens, f is negative because its focus lies to the left. Think of convex as a magnifying glass that brings light to a real point, while concave scatters it like a prankster. And that's it. These rules might seem small, but without them, solving lens problems would be like playing cricket without knowing which side to bat on. Stick to them, and your answers will always be correct and consistent.